Hello and welcome back to another video here at the Hidden Quantum Champion series. Today we are looking at a company called QPerfect, which is working around the software in the space of quantum computers. I think especially neutral atom computers, but I'm not sure. I will learn more about this along the video and I hope you too. So if you are interested in, let's say, learning more about the hardware optimization using software, accelerating fault-tolerant quantum computing for transformative applications, especially with neutral atoms, then you are exactly right in today's video as we are diving deeper into QPerfect. And with that, let's jump right onto their website. So here we are, and it says we make quantum computers work, and I already read it before, accelerating fault-tolerant quantum computing for transformative applications. So what do we have? There is this MIMQ, sets the standards in tensor network quantum emulation. Then QLU brings fault tolerance to neutral atom hardware, and then application-specific quantum computing for real-world advantage. And we will learn about these later on, but now let's scroll through the starting site. We see here the partners, Interac, as an interregional European collaboration ship. There's Quera, which we have already made a video about, Kai Ventures, which is also part of our video series already, Quick, the quantum industry consortium here in Europe. So you see there are many, let's say, relevant partners in here. I didn't list all of them now. Unlocking the potential of quantum computing through simulation today. So Mimic gives instant access to industry-best state vector and tensor network quantum emulators and managed cloud compute resources, pushing the boundaries of classical and quantum computing. So Mimic, with a Q of course, is mimicking a quantum computer. I guess that's why it's called like this. So it is simulating, emulating what a quantum computer is doing. There are different ways of doing that. State vector simulation is one of them. Then there's also tensor network mentioned here as well. And it runs, on classical computers, and there's also quantum computers mentioned here as well. So prepare end users, identify platforms, benchmark, and new algorithms are what you are using Mimic for. Then we have this part here with the QLU, so Quantum Logic Unit, bringing quantum advantage regime applications to early fault-tolerant quantum computers. So compiling high-level algorithms to efficient execution on neutral atom quantum processors, incorporating industry-best gates and QEC protocols, quantum error correction protocols for neutral atoms, application and hardware-specific error correction with minimal overheads, and then cutting quantum resource requirements by orders of magnitude compared to general methods. So we see here the idea is to make use of these, I think we saw it before, right? Neutral atom processors. If you don't know how a neutral atom computer works or what it is, please go check out our Hidden Quantum Champions playlist. Just as one example, we have been featuring Pascal, which is one of the companies that is active in that space. But there are also other ones. Go check out the Hidden Quantum playlist to learn more about those. So incorporating industry-best gates and quantum error correction protocols. So quantum error correction, what is this? If you have today's quantum computers, they are making errors while they are running on the computation. And actually, it's not super easy to correct for those because you cannot just create a copy of a bit. That's forbidden by the non-cloning theorem. So you have to kind of come up with creative ways to figure out whether the qubit that you've been working on preparing a state on, like entangling with other qubits, running superpositions, if that one has been undergoing some kind of error, and then to correct for those. And that's the idea of this error correction protocols. Quite complex research field in itself, and that is indeed something where there's still a lot of research happening, still a lot of optimization happening. And as we see here, it is something where also hardware-specific knowledge comes in and can be used to make it more efficient, especially in today's era where the number of physical qubits, so the non-error corrected ones, is still very much limited. Quantum advantage over the real world, so that's then I've explained here, application-specific quantum computer powered by cutting-edge simulation and fault-tolerant compilation. So lightning fast, research-grade, cloud-ready, dynamic circuits, open ecosystem, and expert support. World-class expertise, a team of 10 plus PhDs with decades of hands-on quantum research, scientific software, and deep tech experience, leading major French and European efforts in neutral quantum computing. By the way, the company is based in France, close to the German border in Strasbourg. I think we will also see that later on in today's video. I'm recording this in July 2026, and you can see here that the news and insight section is very much up to date. There's already news from July in here available as well, including BTQ Technologies completes acquisition of QPerfect, so it's now part of BTQ. When I added it to the list, I can promise you that was not the case yet. That is very much new still. So here's how you start your path to quantum advantage. So find a good problem, benchmark the approach, develop with Mimic, validate on the digital twin. So that's now the second point. They have a digital twin platform, and then finally compile with QLU to run on an actual piece of quantum hardware. That's, let's say, the rough overview. I think that's also kind of what these three products are doing, right? Quantum computing, Mimic, and QLU. Let's quickly start with the quantum computing, because I think we have not talked about that too much. So quantum computing, accelerating the path to fault tolerance, chemistry, materials, large science optimization, cryptography. The hardest computational problems are running into the limits of classical hardware. Quantum computers can attack a growing class of them once their errors are low enough for useful algorithms to run. And then there's some explanation here about the fields. I think we've seen that also in previous reviews, both of hardware companies and software companies. Typically, we talk about insurance and finance, like portfolio optimization and all of that stuff, right? There is logistics and energy, for example, the traveling salesman problem, where we have also been working on tutorials already at the School of Quantum. Materials and chemistry. Kind of makes sense that if we are looking into quantum computers that can use quantum mechanics to actually run computations, that you can use them also to run computations about quantum mechanics, which is usually relevant on that atomic level. So hence materials and chemistry. And then cryptography, which relates to this whole quantum communication, harvest now, decrypt later, and quantum encryption topics. Today's quantum bits make mistakes. A classical bit is a switch, a quantum bit is a single atom, a stray photon, a faint vibration, a breath of stray heat, and the information is gone. So 1 divided by 1000 errors per operation on today's best quantum hardware versus 1 over a billion or billions errors useful algorithm can tolerate. So there's still orders of magnitude between the two of them, right? 1000, 10,000, 100,000, 1 million, and then again 1000 million would be a billion, and we are talking about billions here, so orders of magnitude array. Here it says a gap of 6 orders of magnitude. There are only 2 ways to close this, and then build cleaner machines. So that's this whole idea of error mitigation, right? Better atoms, quieter lasers, smarter pulse shapes, yada yada yada. And then quantum error correction on the other side. So spread one piece of information across many noisy qubits, detect and correct errors continuously as they happen. That's what I was trying to explain before. About the company, 5 co-founders, 14 full-time engineers, founded in Strasbourg, 2023, 3 product lines, 1 stack. That's what I talked about before, right? Mimic, digital twin, and the QLU. And then some further facts down here. So 1024 largest MQT circuit solved, 13 MTQ benchmarked at 100 plus qubits, 65 qubits Grover factoring, and then QDA-Q, which is the NVIDIA stack that is integrated into that. Some more information about the platform and Mimic. Here you also see, I think, a couple customer use cases. BTQ, which is now an investor into the company or bought the company. Quera is also mentioned here amongst others. 3 phases, 1 destination. I think that's kind of clear, right? So you have the hardware, the validation and the blueprint, hardware integration, and then the commercial advantage. And then where do you start? That's kind of the, let's say, explanation of these different stages that we saw before. With that, a quick look at the resources. So there's a newsroom, a blog, a research, and documentation. Quickly going through the newsroom again, right, regarding the BTQ acquisition. So this has been completed in July 2026. We also see other points here. BTQ's QPerfect powers the commercial launch of SDT Curica Quantum. Then BTQ Technologies receives final approval for full acquisition. QPerfect and SDT launch Mimic powered quantum emulation service. BTQ exercises option to acquire QPerfect, continuous tensor network simulation. Here we see the Interact communication from before, and strategic partnership, which has been announced in June of 2025, so a year ago, and then 1 year after you have the acquisition. Quickly about the company. As per usual, so born in quantum science, built for industry, QPerfect was founded on the conviction that quantum computing will redefine every industry that runs on compute. The only question is timing, and we intend to set the pace. Spin out of the European Center of Quantum Sciences, QPerfect was founded in April 2023 as a spin out of the European Center of Quantum Sciences, CESQ, at the University of Strasbourg in collaboration with the French National Center for Scientific Research, CNRS. Our 3 academic co-founders, Johannes Schachenmeier, Shannon Whitlock, and Guido Pupillo, bring decades of combined experience in quantum computing, numerical simulation, and neutral atom physics from world-leading laboratories. The leadership team includes Philippe Bolt as CEO, contributing extensive business development experience to translate deep tech research into commercial impact, and Guido Marcella as CTO, bringing deep expertise in neutral atom physics and high-performance software for simulating quantum systems. The company emerged from a pre-maturation program supported by SATT from the University of Strasbourg and so on. Today's state-of-the-art quantum emulators remain one to 2 generations ahead of real quantum computers. QPerfect builds the software that bridges the gap, turning quantum promise into quantum performance. 5 founders, and then 17 scientists and engineers. We see here this Access quantum computer with Q, of course, in there, QC. So France's first public neutral atom quantum computing platform is this Access that they were talking about. 400 plus qubit target capacity, and first public neutral platform in France. At the heart of Europe's International Quantum Corridor. That's the idea of this institution in Strasbourg. Then there's some video here and some more information about the supporters available as well as the QPerfect transition into BTQ. I think that's already it. I don't want to keep it for too long for today. I hope you found this interesting. If so, please make sure to give it a thumbs up and make sure to subscribe if you have not. I know that more than 90% of the people watching these videos, they are not subscribed. So if you stayed all the way until the end, you should subscribe. And with that, as always, stay hydrated and see you in the next one. Bye-bye.